Good day. Assalamualaikum warahmatullahi wabarakatuh. In the previous video, we have described the data in detail using a data dictionary. In this video, we will discuss the process description in more detail through the specification of process and structure decision, using three kinds of approaches that can be seen in the following figure. The first one is structured English, the second one is decision table, and the third one is decision tree. Before determining these three forms, the types of processing also needs to be determined in advance, whether it will be processed online, in batches, or manually. Structured English is a form of process specification approach using English, which is structured in its delivery pattern. There are four types of structure that can be used as shown in the figure here. The first one, sequential structure, where the process is described in the form of a sequence of actions. For example, action 1, action 2, and action 3. And the second one is decision structure, where the process is described in the form, if a condition is true, then take action 1, else take action 2. If condition is true, then action 1, else action 2, and if. The and if sentence is needed to close the structure so as not to enter into a circle of the if cycle. The third one is the case structure, where the process is described in the form of special event cases, meaning that when one action is executed, another action cannot be executed. For example, if case 1, action 1, else if case 2, action 2, else if case 3, action 3, else print error, and if. The fourth one is the iteration structure, where the process is defined as a repetition of an action or several actions when a condition is met, and ends when the condition is no longer met. For example, do while condition met, action 1, until condition is no longer met, and then end do. The following is an example of structured English for the process of determining the number of inventory available, as shown in the figure. There seems to be an error. This should not be the greater, but should be lesser. This process can be described as follows. If the number of inventory ordered is less than the available quantity, then move the data on the quantity ordered and the order code to the available quantity and the inventory code to be sent to the next process. For example, the process of displaying the inventory code and quantity available on screen. This condition provides a decision. If the inventory ordered is available, then display the number inventory that can be ordered. If the condition is not met, when the number of inventory ordered exceeds the available quantity on hand, then subtract the number of available inventory from those ordered. The difference becomes the number of backordered inventory that will be written into two columns, which is the backorder item code and the quantity of the backorder items in the backordered items record. This data will be sent to the purchasing department processes or the inventory control process. Meanwhile, the quantity on hand that can be ordered will be moved to the available item quantity, together with the order item number will be moved to available item number. There is actually another condition that has not been set on the action here, which is when the quantity on hand equals to the order item quantity. The second form is the decision table that shows condition and alternative conditions and actions for each condition or combinations of conditions in a table containing columns and rows. An example of a decision table can be seen here. This figure illustrates the process specification at checkout. First, when the payment is below $50. Second, payment by check. And third, payment by credit card. Those three previous conditions leads to 4 different actions. A. When the transaction is completed after the check is signed. B. The transaction is completed without any sign needed. C. Calls supervisor for approvals. And D. Authorizes the credit card electronically. The 4 actions and 3 conditions are connected to 4 different rules. Action A, when conditions 1 and 2 are met. Action B, when conditions 2 and 3 are met. Action C, when conditions 2 alone is met. And action D, when conditions 3 alone is met. In making a decision table, there are some special situations that can arise. For example, 1. Where we can combine several rules into one rule because there are similar conditions and actions that are fulfilled, as shown in this figure. Rules number 2, 4, 6, and 8 have one condition and action that is in common, which is condition that the customer doesn't order from the special catalog and the action of sending the Christmas catalog. And so the 4 rules are merged into rule number 2 in the new decision table. This is also true for rules 1 and 5 from the old table, merged into rule 1 in the new tables. And rule 3 and 7 from the old table, merged into rule 3 in the new table. A second situation arises when adding new rules in the form of new conditions and new actions. This will change the whole table because there is a possibility that the new conditions and actions will be fulfilled by the previous rules as seen in the figure here. A third situation is where a rule that creates logically impossible conditions that may occur, as shown in the figure. It is impossible that the conditions for salary above $50,000 per year and below $2,000 per month or $24,000 per year could coincide. The fourth situation is where contradiction and redundancy can occur. Contradiction is when the conditions are the same but the action is different, while redundancy is when the conditions and the actions are exactly the same. As can be seen in the figure, rules 1, 2, and 3 have the same conditions but different actions, and rule 4 and 5 have the same conditions and actions. This can occur because there is an error when combining the rules. For example, conditions 3 in rules 4 and 5 should be shown as met or not met so that they can be distinguished. The third form of the process specification is the decision tree. A decision tree can describe the process specification and the structured decision based on the sequence of events. For example, for the previous first example, the decision table can be described as follows. In this figure, we can see which conditions are sequential and which conditions are concurrent. For example, a payout conditions under $50 is the first order along with a payment conditions over $50. The second order sequence that occur concurrently is payment by a check or credit card, and so on until the action for each condition can be seen. Looking at those 3 forms, then a question will arise. When should we choose a suitable process specification form? First, structured English is used when there are many repetitive actions or when communications with users is very important. Second, decision tables is used when there are complex combinations of conditions, actions, and rules, or when an effective approach is needed to avoid an unlikely situations, contradictions, or redundancy. And 3, a decision tree, when the sequence of conditions and action is important, or when not all conditions are relevant to all actions. For example, when the branches are different. Apart from process analysis using DFD, data dictionary, and process specification, there are several other alternatives to do so. One of which is the object-oriented approach. In this subject, we will not discuss this in detail. We will still focus on the data flow diagram modeling only. However, just for your information, the object-oriented approach is an analytical approach centered on entity objects and database-based data. The process is described using unified modeling language based on use case modeling, as in the example in this picture. This figure shows the registration process for students. There are 5 actors here, namely students, departments, bookstore, financial office, and the registration department. For example, communication between student actors and the registration actors occurs in the use case of add students, in which it includes the use case of verify identity. In such case, when new students want to register, they need to log in using their username and password. For more details on understanding the use case model diagram, please refer to Chapter 2 of the book. There is a use case modeling sections on Chapter 2 that describes the use case modeling in more detail. That's all that we can discuss. Thank you for your attention. See you after the mid-exam. Assalamualaikum warahmatullahi wabarakatuh.